Here's our key for the Fundamental Theorem of Calculus Part 2 study guide. With problem number 1, we're told that x is positive, and we're asked to find the derivative of the integral from 0 to 2x of natural log of t cubed plus 1 dt. So, we're using our Fundamental Theorem of Calculus. We know we're going to replace t with 2x. So we have the natural log of the quantity, and then we're going to have the quantity 2x being cubed plus 1. Keep in mind that because we have an inner function of 2x, we are doing the chain rule, and therefore we have to multiply this expression by the derivative of 2x, which means we need a 2 out front. All right, so that eliminates a bunch of our answers, and in fact, we now just have to make sure that we cube out the 2 and the x, so that gives us twice the natural log of 8x cubed plus 1. Our answer is D. Number 2, we're given the graph of f shown above, and it's 2 line segments in a semicircle. G is the integral from 0 to x of f of t dt. What's the value of g of 5? Well, g of 5, I guess we can put that right up here. G of 5 is going to be equal to the integral from 0 to 5 of f of t dt. So we're going to start at 0, which is our y-axis. We're going to end at 5, which is the end of our semicircle. So we need to find all of the area that we accumulate in this region right here. What we have is the center of our circle at 3, so we have a radius of 2. All right, and then over here for our triangle, we have a base of 1 and a height of 3. All right, so the triangle, that's going to give us an area 1/2, 1 times 3. And the semicircle, we know is pi r squared over 2, so it's pi times 2 squared over 2. So this is 1.5, and this is 2 pi, so we're looking for 1.5 plus 2 pi, and once again, our answer is going to be D. For number 3, we have a limit, so we're going to plug in 1. Now when we plug in 1 into the numerator for x, we have the integral from 1 to 1 of e to the t squared dt. Well, the lower bound and the upper bound are the same, so that's equal to 0. When we plug 1 into the denominator, we have 1 minus 1, which is also equal to 0, so we end up having 0 over 0, which is an indeterminate form, which means that we want to use L'Hopital's rule. So that means we're going to continue to take the limit as x approaches 1, but we're going to derive both the numerator and the denominator. These are 2 quick derivatives. Deriving the numerator, we replace t with x, e to the x squared. Deriving the denominator, x squared derives to 2x, 1 derives to 0. L'Hopital's produces this new limit, and now when we plug in 1, we have e to the first power over 2 times 1, or half of e, so our answer is going to be C.